Shall we go? Okay, thank you all for coming. I'm Ram Seshadri, data scientist, instructor, consultant, whatever you call it. So I'm here to talk to you about faster time to insights. I know a lot of you have heard of AutoViml or automated machine learning, and some of you may not have tried them, but at least are curious about it to come here and want to know more about it. So I'm going to give you a little bit of insights into what getting faster time to insights means. A lot of people get asked this question from their boss, CIO, whoever, and it's all about, so a lot of people ask questions. Shall we lower the volume?
No, that's good. That's good.
Okay, all right. And this question came up to me as well, which is, why is your data science project taking so long? Everybody's under the impression a data science project should take about as much time as a Kaggle competition, which is about 24 hours to 48 hours, right? Or some competitions run for months at a time, but you know that when you get a data set from Kaggle, it's already very clean or somewhat clean. It's in a very structured format. All you have to do is to do some EDA, choose the XGBoost model or Light GPM, whatever the flavor of the day is, and then you will get a decent model going in a short hour. So when we ask actually a lot of data science teams, and this is my 6th or 7th meetup where I'm presenting, what I found was that most people had different answers to this question. Why is your data science project taking so long? Any suggestions or any experiences from your end, anybody? Why, if you were asked this question?
I think the cleaning part takes...
Training part takes... The cleaning part takes a long time, absolutely correct.
Yeah, also maybe deciding which type of model to go for and like the thinking behind that, and then maybe changing track, realizing that neural better than logistic regression or something like that.
So choosing a model and explaining it is very hard. Any other suggestions or experiences from the front lines? So I have found that in many of the projects that we have worked on, the size of the data, the quality of the data, the quality of the tools you're working with all have pretty big impacts on your results. So quality, meaning it's everything. So it's about, one answer is, inflexible frameworks, lack of reproducibility, being able to reproduce what is in some tool. I'm going to show you some tool here, but one of the advantages of this tool is it's got some interpretability, it's got some openness built in, but there are many tools that are black boxes, and we're going to try to address those. So collaboration issues and software tools, these are some of the ones. First thing, somebody talked about insights means I want to know what my data is, and I want to get some understanding of the data. So cleaning the data means I need to understand the data, which features to keep, which features to delete. So one of the things that I think would make data scientists more productive is faster visualization. If I can visualize my data without having to write thousands of lines of code every time I got a new data set, it'll be nice. So we're going to see that. The second part of that is automatic feature selection. This is again not about cleaning data as much as which features are really important, which ones are not. And doing this is pretty much a data scientist's major part of their job. A lot of times in Kaggle you get 30 features, sometimes 50 features. I've seen real world data have thousands of features, in which case if you take all of that and put it into a model, you're going to get very poor results. And you're questioning your boss or your managers then saying, I gave you all this data and you're telling me that it's not good enough. Find the variables that are important among the 5,000. So then it becomes your job to find among the 5,000 which ones to keep and which ones to throw out. And that is a very long process. So that's a second thing that will make people more productive. If we get to this, third is automatic model selection. This goes back to whether you should choose a neural network or a simple logistic regression. And if something can help us do that, that would be helpful. Last is one-click model serving production. This is somewhat interesting, and it comes back to building a pipeline of data so that once your data is all transformed, you can apply that same transformation to the test data that's coming in for prediction. And one of the last few years I've been working on this problem, and this is my personal project. It's not related to anything that is related to my employer or my past employers. These are the projects that open source are my personal work in the last 2.5 years outside of my work I did for my companies. And so one of the things I found about current tools while I was working with a lot of tools, I was previously at an investment bank as a data scientist, and they had a tool called Data IKU or Data IQ. I don't know if you've heard of it. There are other tools that are like Data Robot, and there are any number of tools like H2O, driverless AI, and so on and so forth. So a number of these tools exist, and they are excellent tools, and they make you more productive. But there are some downsides to that. They're expensive. Not everybody can afford them. And second, you are locked into one vendor's methodology or tool. You cannot just take what's in theirs and move it to another tool except the model. But you don't get to transfer the pipelines or anything like that. Second is they're black boxes. Some of them don't really help you reproduce what they are able to come up with, because though they have nice charts and graphs, you still cannot reproduce what you get out of that toolbox very easily. Third, the same point, which is you cannot reproduce what's in the tool outside of the tool with your own Python code. You may not get the same results. So I decided to create a simpler approach to AutoViml, and I call it AutoViml or AutoViml. And AutoViml is a ML library that with one line of code, you will be able to try multiple different models on the same data set. And you should be able to create a baseline model within a few hours or a few minutes, depending on how big your data set is. The second one is called AutoViz, which is a similar kind of a library, and it does automatically visualize any size data set, and again with a single line of code. And you should be able to then decide which of these charts are helpful for you to be able to either derive some explanation or insights from your data. You are not going to able to have that tell you what the insights ought to be, but looking at them you should be able to tell it, and that's what we are going to look at today. Any questions while I'm rushing a little bit so I can actually get into the demo and stuff? Yes, Harry?
So this is not the AutoML from Google?
No.
Okay.
Oh, the AutoViml from Google, there are a number of people who do, present across the industry, and Google itself has like hundreds of videos to talk about. Hopefully, you can see them. But I'm not here to represent Google or, present any particular product just from Google. I'm here to just talk about this library that I open sourced a few months ago that is available for everyone to use. Yeah. So, what is AutoViz and what is AutoViml? Both are open source tools for faster time to insights. Both are simple. You invoke them from the Jupyter Notebook, single line of code, flexible, suited to any kind of data set, structured data. I'm not dealing with images or NLP yet. Incremental can be used by anyone, from beginners to experts. In experimental, it helps you create multiple visualization methods and models from the same data. This is very helpful when most of your work as a data scientist is experimentation. So when a tool is limited to only one way of working, then it becomes very difficult for you to modify the tool to let it try different other things, because it's meant to work a certain way. The last or couple of 2 points is interpretable. Again, you get greater explanation from these two tools with validation graphs and charts, and you can increase the level of verbosity that you require in order for you to understand and make decisions. No black box, all the pipelines, even the code is available, so you should be able to look at the code if you have to. I have had contributors come in and they are able to make suggestions, or they're able to take this code and reuse it into something else very easily. So you're welcome to do that. Open source with contributors coming in from Python and others. So I built basically AutoViml over the last 2.5 years to make my life easier as a data scientist, and I hope it will do the same for you. That's the idea. What is AutoViml? AutoViml is basically like it, inspires. It enables you to automatically visualize any size data set. You can, to do that, you have to remember two things. You have to do 2 or 3 things. When you write your matplotlib code, the matplotlib line or seaborn or plots that you do, they work for a single data set. And even if the column names change or the types of each of the individual column names change, you are constantly rewriting that code. And whether you write it for Iris, it doesn't work for Boston data set, and Boston doesn't work for the Titanic data set, Titanic doesn't work for the breast cancer data set, breast cancer data set doesn't work. I'm just giving you some examples of data sets that are very popular. And you are constantly writing code. All for what? To visualize what the data means. And wouldn't it be nice if we were to take any data set and for the same set of charts that I need to produce, I could have a generic template that produces all of these charts that I need to see as a data scientist for these data sets, right? That was the challenge that I was pondering when I started on this journey about 2.5 years ago. Why are we writing this massive amounts of code, all of us? Collectively, there's probably millions of lines of code that's just spent in visualizing the same data set, copy-pasted from Stack Overflow 10,000 times, right? And it's all visualizing Iris, 100,000 ways. Same data set and the same line of code. It's not even from a central place. It's just copy-pasted. And this is considered productivity, right? This is considered, paying your dues and so on and so forth. All of that is fine. It's good to learn. But once you are at this point, let's say 2.5 years into data science, now what? You're still writing basic code when I give you a data set, right? All of us. And that's the problem I decided to tackle head on. So in order to do that, you need to first select a random sample from the data set. If your data set is like millions of lines, millions of rows, billions of rows, you don't need to visualize all of it. Nobody visualizes all lines of a data set. I know, because I work with some very large companies with very large data sets. Even they don't visualize it. So what we do is instead we take a random sample. It's a statistically valid sample, and that's what it does. So if you can feed a data set into a pandas data frame, and if it can fit into a pandas data frame, this code is perfect for you. If your data doesn't fit into a pandas data frame and it's in some other format, in like Spark, it's in, let's say, I don't know what format it's in, and you then take a random sample from that, and that can fit into a pandas data frame, then call AutoViml. So somebody asked me, Ron, why don't you write it so that it can fit petabytes of data and can visualize petabytes of data? Like, nobody visualizes petabytes of data, there's nobody. Because everybody takes a random sample, because the amount of pixel space on screen doesn't fit petabytes points, right? There's only 1,000 points that can fit into some of your screen sizes. So if you had a scatter plot, maximum your eyes can distinguish about 70 different points on a chart. And as I shrink the chart size, you probably get to like 20 points. So this is something that people haven't gotten into their heads yet, but they're beginning to understand the scale of the problem. As I talk about it to various groups, they're like, holy shit, P's right. We are writing massive lines of code that are just doing very simple things. So the first thing you need to do is random sampling of the data, fit it into a data frame, call AutoViml. Second thing you need to do is select the most important features. This sounds easy, but it's very, very difficult. If you have a data set and you have, like I said, 5,000 features, visualizing 5,000 features will take a lifetime. You will have to write code that would generate just pairwise interactions, scatter plots of two variables each, 5,000 times 4999 divided by 2, right? That's, 5 times 5, 2.5 million divided by 2, that's about 1.25 million charts that you have to see. So there is not enough time in the day to visualize just a simple pairwise interaction scatter plot of 5,000 variables. So where do people get the idea that they need to visualize petabytes of data? I don't know. Right? And I always get asked this question, does your tool visualize petabytes of data? Even today, there was somebody asking me, does your tool help visualize petabytes of data? I'm like, do you have enough time to visualize petabytes of data? Even if we were to do it for you. You can't. So you need to reduce it down to the most important features. And that's where this tool comes in handy, because it visualizes, it reduces features 99%, sometimes. So I once fed it a data set with 5,000 variables. It found that there were only 50 features that were important. That's a reduction of 99%. So then it visualized those 50 features for me automatically. So that's a second step it does. The third step it does is it selects the best methods. Many of the time, we give somebody a data set and he or she does visualize a scatter plot and so on and so forth, without understanding that for that particular problem, you need a KDE plot, or you need something specialized, or you need a box plot, or you need different kinds of plot. And then as they get more experience, they come to the realization, oh, for regression, I need these set of charts. For video classification, I need a different set of charts. For clustering, I need a different set of charts. Well, that's 2.5 years of experience. So instead, just trying to give it to you by saying that you can have that in this tool, because it automatically selects the best charts for the problem that you have. So those three are done, and the fourth one is whether you want to save them. So we'll come to that next. So what are the benefits? Benefits is systematic. It goes through the problem systematically rather than depending on anyone's insight or intuition. It's simple. It reduces features to the bare minimum that you need to know, and explainable. It helps you explain your hypothesis and your variable selection better to others. So the next one is the design goal. What are the design goals we started with? We select the most important features. So in order to select the most important features, I use XGBoost, which helps in one way, which is feature affordances. I don't know if anybody has tried feature affordances in tools like XGBoost. And so if you were to repeatedly use or run XGBoost, you will get different feature affordances every time you run it. That's because the stochastic nature of the tree and the boosting algorithm, the tree methods and boosting algorithms, they randomly decide what trees will have what features. So depending on how many times you run it, the important features will change every time you run them. So that's a problem, right? Because if you go to your boss and say, out of the 5,000 variables, I found you 50 features, and he says, great, let's come and see it. By the time you come to your desk, you click the run button again, it comes up with a different set of features, and he's like, you just showed me this feature is the most important, and you're telling me this is important? What's wrong with you, right? And the problem is that the stochastic nature of the trees, right? So I solved that problem. So to come up with a stable list of features over and over again, you have to run this multiple times, and you have to find the common features in all of those, right? So if you run it a few times, the features that are going to occur as important in those also happen to occur in a few more times. So then you pull them together, then you will get a stable set of features that if you run this algorithm again, you will get a set of important features that are stable. So then it selects the best charts, delivers them fast. All of this is done in seconds. So that's good news for small data sets, and it'll take in minutes for somewhat larger data sets. And if you want to run for the truly, million rows, 10 million rows or whatever that you feel are your samples out of billions of rows, then you probably need a server to run them, and you'll probably run in about a few hours to get you the charts you need. All right, any questions so far? Don't know, sure.
How many times do you decide to run XGBoost?
Yeah, good question. So currently the way I've configured it runs about 5 times. Variable classification. One of the things that you recognize very early on when you work with multiple Kaggle competitions data sets is that the variables have types. And instead of dealing with variable names, if you were to only deal with variable types, then you'll be much better generalizing somewhat your charts. Because your charts can then run on categorical variables versus numeric variables, and when you try to pair them together, you get bar charts. When you have just numeric variables and then you want to visualize them scatter plots. When you have categorical variables with categorical variables, so you start to develop some intuition about patterns. And that's what those intuitions have been written into code, so that you don't have to think anymore. You can just trust this tool to repeatedly generate those for you. Because it takes into account the variable classification, understanding what each variable type is, and then it understands what problem it is you're trying to solve. So if you're trying to solve an ML problem, it looks at it as a regression or classification problem, and then it decides what interactions are best, what variable interactions are best. So this is how it looks on you can do it on an iPad, you can run it on anywhere, sorry. All right.
Going back, could you go back to the last slide?
Yeah.
So regarding the whole selecting the most important features, have you looked into Shapely values at all?
Mm-hmm. Yeah.
Are you using Shapely values?
So I'm not using it in AutoViz right now, but I'm using it in AutoViml, which is the variable model selection tool. AutoViz, I'm pretty happy with XGBoost's feature affordances, but I felt that for the model selection, it was a little more nice to have Shapely values for people. So I'm using Shapely values in that one. In this one, I'm not using it, but something to consider in the future. But definitely a very good idea. Okay, so if you look at the charts and the results you're going to see, the first thing you're going to do is pip install AutoViz at the very top step. And then the second is to import the AutoViz class. AutoViz class is where you hold all the charts. Because if you don't have an object to hold your class, your charts, they will just be presented on the screen, but you don't have an object to hold the charts, which you might want to process later on. Like you want to save some of these charts and stuff as SVG, PNG files. So that's why there is an AutoViz class which you import. The AutoViz class is a method called AutoViz. So you just call the class.method AutoViz, and you pass it the data frame, and it will just start to visualize it for you. Nothing else is needed. You don't need to tell it what features you have, what kind of features, what type of features. All of those are interpreted, understood from your data set with one line of code. Right? So, you can either send in the file name and the separator in your file, the target variable, or you can send in the data frame and the target variable. Those are the only two things it needs. I just want to give people a choice between loading a file or loading the data frame into AutoViz. So you can choose one or the other. If you read the documentation, it'll be clear. In this case, I'm not giving it a file name, so I give it a string, an empty string, it's called. The separator is like a comma or a backslash tab or whatever you have as a delimiter in your data. So when it reads the data, if it's German numeric data, the comma means a period and the period means a comma. You don't want to go into a problem where I read the data wrongly and there's no way to fix it because I've hard-coded it or I've coded it for you to no way to tell what the separator is. So if you have a special separator, I've seen financial data where there are some very special characters they have inserted just to make sure that's the only delimiter that nobody else will use. And that's perfectly fine. You pass the delimiter, it's like a question mark or some delimiter, that's good. Okay, so the downloads of AutoViml keeps bouncing around. I think it, get about 300 downloads a month, which is, a small number. And the idea is hopefully, over time people come to use it. One of my buddies, when I mentioned to him, he said it's either the most useless tool or it's the greatest tool because everybody wants to not tell anybody else about it and only they want to use it. I'm like, that's not possible. So take it for what it's worth. All right, so here's insights from the scatter plots that you're going to get on our Boston dataset. If you send in the Boston dataset, it's going to immediately recognize that there is numeric variables like room size and age, and you can see that it's plotted against the target variable median value of homes, and you can see there's a nice nonlinear but trending upward line of the median value of homes on the left side as the room size increases. And you can see on the right, as the age of the home increases, your median value falls. And you can see at the bottom as the NOx, which is like either nitrous oxide or nitric oxide, I forget which one. But as it increases your home value, the distance, there's a kind of a nonlinear correlation, and the PT ratio with NOx has got like a nonlinear correlation. All of these things are done for you automatically without you having to write code every time to visualize them. So it takes it takes an understanding of the data set in order to do this. Yes, Harry.
I was just curious, so is it making a decision of what the best visualizations are? And
Yeah.
How are you measuring the goodness of a visualization?
Yeah, no, it's a great question.
Is it just variance or?
It's not that, it's all of them. I show all of the charts that are possibly doable out of that data set. So if you have 5,000 variables, that's why I said visualizing all pairwise interactions of those is not possible, or there is not enough time. But it will reduce it down to 30 or 50 using variable feature importances, and then it will choose to show all of the variable interaction charts.
Oh, so it generates a lot of visualizations.
Yes. So for a data set, let's say, of 10 variables or so, the different charts it will produce is around 300 or so. For the Boston housing days, the data set produces about 100 charts. 100 different charts. Which, depending on your point of view, it may be either too many or too little. I've had, bosses come to me and said, let's give the same data set to a couple of different data scientists, let's see what they come up with. All of them come up with the different interpretations of what the data set means. And then the boss has an insight. He says, what about this variable interacting with that variable? And they're like, we don't think it's that important. And guess what? Next session, somebody draws, the variable interaction. It is important. The reason is, when you are not systematic enough to going through all of the variable interactions, then you just depend on domain, gut, or just experience, and so on and so forth to narrow down what you think are the best variables. And sometimes that's not good enough. And this happens frequently, I don't know, it happens a lot in financial services, where the data scientists report to a manager who's either from business or experience or whatever, and has a different understanding of what the data means. And unless you're systematic, you are likely to find that your domain experience quite does not match what the manager's experience is. So when you come up with what you think are important variables based on your gut or your understanding of the data, and it's not a systematic approach, you pretty much get to the point, example I told you. You present, you get challenged, you find later that you're wrong. Right? And so to avoid that, my experience has been that we sit with my manager and he says, let's look at the data set. We run it through AutoViml. Let's have 400 charts. We sit in the conference room and we actually visualize the charts. And he says, just keep rolling, and we just keep moving through the charts. And he says, that one, that is very interesting. So we see like a pattern, and then we say, we're going to use that tomorrow for the presentation to the CIO. So we go through 400 charts in about 20 minutes or 15 minutes, and we can see visually which charts make sense. So based on that, one of my colleagues says, Ram, you give all your charts, feed it to a machine learning model for object detection or image, and we find what the common patterns are for interesting charts, or what people label as interesting charts. And if a certain chart fits an interesting label, we then show only those charts, right? So that's something that we might do, sometime in the future, because I find that idea very intriguing, that we might take up on it someday. But the idea is that what a human being is able to get from a chart is very different from what a machine currently views as an interesting chart. And when I say interesting, it means something that a CIO would view as interesting. So it may not be your view or my view. So keep that in mind as well.
Yeah, it's not interest, it's meaning. You're looking for the most meaningful charts.
Exactly. Sometimes I see interesting in the sense that there is a commonly held myth or a view among the community in the company that certain variables are very important, and they've had that view for a very long time. And now when we suddenly put them in charts and we see that it has very little impact, then they start to get, when that chart is very interesting, even though it has no pattern in it, but it's an interesting chart because the variable that you're displaying is very important. Okay, so I'm going to show you some histograms so that you can make your understanding of whether these variables have highly left skewed distributions, right skewed distributions. All of those are very important for you to see. You're going to get some heat maps. You're going to get some bar plots of categorical variables against continuous variables. So that's pretty much how AutoViml works. I'm happy to take any questions, but we can go to the demo. Okay, so I'm going to go to the.
So I mean, just to clarify, so would you say that these two toolkits are best for structured data problems and not like
Absolutely meant for
perceptual deep learning type problems?
No.
So more like business applications then?
They are absolutely meant for structured data. Okay, here's the demo data set that is in the GitHub. So I'm just going to use that in order to see it in action. I just want you to see here. Okay, I typically move my data around, and this happened last time as well. It says that wide quality data doesn't exist, and I have to remember where I put it. Okay, so let's try the other data set. Boston data set. RFS demo. And
Is the Boston one the housing?
yeah, so the Boston one is the housing, now I figured it out. Okay, so the Boston data set is a famous data set. It's a housing data set from the 1970s, about 506 rows. I'm able to, the name of the variable is median value. So it's going to generate about 55 plots. That's what it says on scatter plots alone. Like I said, the Boston data set has 14 variables, so it will generate about 100 charts or so. It took about 14 seconds to generate 100 charts on my laptop. So the first thing we're going to see is that each variable in numeric variable is plotted against the median value, which is the target variable that you've given. The target variable is the one that you're trying to predict. In this case, it's a numeric, which is median value of housing is a numeric variable. So for you to see each variable against the target variable gives you an idea of whether this variable has any correlation to the target variable. You can see some charts here. This particular one has a high correlation, whereas age has like a somewhat non-linear correlation. As you can see, it's also not very clear. The median value here also has a very non-linear correlation. After about 20, it drops pretty dramatically. So all of this LSTAT, the lower income percentage, if it increases, then the median value falls pretty dramatically after about 20 or so. In the second chart, list of charts, you see actually the combination, the interaction between each variable against other. So each numeric variable against the other variable. In this case, I don't see too many interesting charts. I typically scroll through this like this, and you can say maybe indices some slight correlation to room. I don't see too many interesting charts. Knox is a kind of a nonlinear correlation. So these charts will be something that you can pretty quickly see and go through 100 charts in about 5-10 minutes. If you wanted to see any particular one, you pause and you look at it. This is the distribution of the categorical variables. So this is known as bimodal distribution. So when you see a bimodal distribution of some variable like tax, it tells you that the tax variable has like two different tax rates, or the amounts that they are applied to, the amounts that they are paying. So there are some homes that are paying about 300 or so, and there are homes that are paying 600 or so. But pretty much in between, there's not much data, right? So this is a right skewed variable. So you can see that the variable here probably might need some transformation. Crime is a right skewed variable. It might need some log transformation. So these are things that will come to you as you look at the data, as you look at the charts. You should have some experience looking at charts. That will really help you become a better data scientist. This is the heat map. It tells you which variables are highly correlated to each other. Here you can see pretty much the average median value. You can make some conclusions by saying that the average median value, the lowest is found if the radius from radial highways or something, as it goes higher, the median value falls dramatically, and the best median value to have is like somewhere around 5. So these are things that you would have some expertise or experience going through charts like this and being able to detect very quickly what you want to do with them. I can keep going on and on, but that's just for regression problems. We're going to change it now to a classification problem. this problem, I think the name of this thing is called quality. So the separator on that, I think is like a comma, if I'm not mistaken. Okay, so now you now you run this. It tries to reduce variables if there were any ID variables. You don't want to take a person's ID and try to derive insights from ID. So typically it removes those kind of variables from visualizing. Like your person's SSN or person's name or something or IDs, it takes those out in the visualization.
How many features are in the Boston data set?
Was 14. In this one, 13. So the number of plots are decided by the number of numeric, categorical, and different kinds of variables. That's what determines the number of charts. If your data set is almost, let's say, 30 numeric variables, that's 30 times 29 divided by 2 is the pairwise interactions that you need. So it's about 450 charts. That's what you'll have to see.
Those ones with the line, with the different lines in the bar charts, that's just the variable itself.
Against a categorical variable. It's the numeric against a category.
Numeric, yeah.
Or it could be,
What is the variable?
or it could be the distribution of that categorical variable. It's how many people, how many are in that category, and so on. It'll show you those as well. It'll first show you distribution, then it'll show you some complex charts that are 2 or 3 variables. So this particular one is a multi-class. It's a nice example of how when the data changes, the charts change. If you have to write this kind of a code, it'll take you a very long time to get good at it. Because, you know, you first have to think about what you want to visualize and what you want to show. For this particular class, quality happens to be a quality of a wine. The quality of a wine varies from 3 to 9 ratings that's been given. And they've tried to understand whether the quality is related to the quantity of acidity, sugar, citric acid, all of those things in it, and they measured it. And once you look at these charts, the quality doesn't seem to vary that much. But if you go down, there will be some charts that will give you some idea. This particular one, it says that as the alcohol quantity in the wine goes up, there's a slight increase in people's feelings about its quality. So, I don't know if it's true or not, but that's what data shows, okay? I'm not making this up.
You wouldn't have guessed that.
I wouldn't have guessed it at all. So this is a chart that shows you the quality as a scatter plot. As a scatter plot, you can see these variables interacting with each other. There are some variables here that are interesting. This particular variable, fixed acidity and density, is almost like a straight line. So they are like a strong band. They might be highly correlated. You need to be able to, look at these charts. Like density doesn't seem to matter that much, change that much with volatile acidity. So keep in mind, you have to get used to looking at charts if you are going to love AutoVis. So if not, this is not the tool for you. If you want to know whether a variable is good at distinguishing a particular class or a quality of wine in this case, you need to be able to look at histograms. And when you look at KDE plots, which are these plots here, you can see that some variables are good at distinguishing a quality of wine all by itself. And you can see here the alcohol. Again, if you have a quality of wine that's in the 5 range, it's got a lower, like an 8-9% alcohol content, whereas at the blue line, which is 9, it's got more like a 12%. Just by knowing that will help you determine the class. So it tells people who are coming up with ratings for wines that one of the important variables here is the content, the alcohol content. Just by looking at these charts. Got it? So I can go on and on because I spent a lot of time studying what charts are useful for data scientists. So all of that is encapsulated in this one particular tool. Okay, so try it and.
How do you determine usefulness?
Yeah, that's a good question. That's what I was explaining earlier. You cannot determine usefulness from just looking at these charts. I determine it from the feature importances when you have more than 30 variables. I've set a limit of about 30 as being kind of the maximum number of variables that you would need. You can increase that to 50, 100, whatever you want, because that's one of the inputs or parameters to, let's say you have 5,000 variables in your data set. It uses, XGBoost to find feature affordances and then reduce the number of features to a manageable number, and then it develops charts from it. But each chart by itself, it does not tell you whether that chart is useful to you or not. That's for you to design.
So, have you able to come up with feature contributions for the accuracy of your features? I mean, those charts can be very useful to explain to somebody.
Yeah.
But can it be used to, like, see this contribution, like let's say for each additional accuracy that you need to be approved, you want to find out whether the feature that you're looking at contributes or
How much,
yeah,
right?
Yeah.
So that's the point he was raising about SHAP values. One of the main inputs to this charting algorithm is the feature affordances, which is derived from XGBoost, and XGBoost uses Gini. So it uses how much a feature reduces Gini in order to arrive at a feature importance. So already that's incorporated into the AutoVis. So when it says it's important, it's not saying it from the importance of it's a good looking chart or a bad looking chart. It's saying it from the standpoint of it's good for regression or the classification problem that you're trying to solve. So that's the point.
Would there be any use to being able to customize how many times XGBoost runs? It's like a really large.
No, that I set it at 5. It runs it automatically inside. Unfortunately, I didn't give that as an option. But in this AutoVis, you can see the maximum rows analyzed. The random sample currently is set at 150,000 artificially, and the maximum columns analyzed is artificially set at 30. So those are the defaults. You can change that to whatever number you want. You can set it to million if you want rows. You can set the number of features to be 50 if that's your tolerance limit for going through the features, going through the charts.
Just quickly, do you use Python.mat for the random? To see the random?
The what?
How do you see the random?
Oh, the seed the random, I use dataframe.sample and set a random seed for it. So that's, I think, tied back to NumPy. Yeah. Cool. So we're gonna stop this. I'm going back to the presentation. I'm going to go through this quite quickly because I want to do the demo of the tool. The next step is once you visualize, the features, how do you build a better model? The number one thing is you need to remove low information variables. You need to add some interaction variables of your own. So if you feel like from the charts, certain variables are interacting with each other and those variables should be added to the model, then you need to provide what's known as, so if you have variables x1, x2, x3, x4, x5 in your data set, x1 times x2 is an interaction variable. That is something that if you add to those who do Gabble, they know that they will automatically add pairwise interactions just anyway. But I give you that option here where you can just set a flag at the top line, and it will add automatically all of those interaction variables, and it will test them for whether they are useful to the model or not, and it will drop them if they're not useful. And then similarly, x squared, x1 squared, x2 squared, x3 squared, all of those could be added to the model as well. So select the models. You can select your own models, complex from simple to stacking. You can add some extra features. In this I found based on my experience that certain features to be added to models help. One of them is clustering the data into different clusters organically, helps the models to perform better. So this is called K-means featurizer, which is basically an algorithm that just clusters it into various clusters automatically and feeds that to the model as an extra feature. Entropy binning. Entropy binning is about binning a numeric data, but taking into account the target variable, so that those that contribute to entropy, at that point, those are binned. So that's also very helpful. And the third one is stacking. So if you were to take simpler models and their predictions as input to more complex models, that also helps your model. So these are three things that I found very useful, and you can turn them on, turn them off. You can add imbalanced sampling. So if you have an imbalanced data set where 99% of your data set is zeros and 1% is like ones, you can add a downsampling. So you just say imbalanced data and it will downsample the majority class so that it will actually get to a slightly more balanced data set. Ensembling, if you wanted to ensemble multiple models, you can do that just by setting a flag. So why is AutoViml very helpful? It's helpful because it mimics how a data scientist would approach a problem, which is systematic. You go from the simpler model to the more complex model. You don't go straight to building an XGBoost model with all the variables, in which case it'll perform poorly. It'll show that you don't know what you're doing, right? Because you basically threw everything in and you just use the most complex black box type of algorithm there is, and you're trying to prove something rather than trying to find out what's in it. So you want to start from the simplest model, the fewest features, to the more complex model and see how adding an extra variable or adding more complexity, whether it improves or does not improve the model. So models with fewer features result in better models or simpler models. AutoViml produces sometimes models with 10 to 99% fewer features than what your data set already has. Some people are very surprised by the statistic until I show it to them and they're like, holy cow, I really have been using more features in my data than I should have. Okay, all of this is just feature engineering, add some features. So these are flags you can set: boosting versus bagging, ensembling, stacking, imbalanced versus balanced, grid search versus random, feature importances. I recently added all of these things are kind of options. You can set the interactions to no interactions, 0, 1, pairwise, which is like I said, x1, x2. If you set it to 2, you'll get squared variables. If you set the variable boosting or bagging, now I'm using something known as cat boost. This is something that people have been asking me for a long time. And finally, I decided to incorporate it. Cat boost is an algorithm that's a version or a different kind of XGBoost, but works very well for categorical data. So if your data set has a very large number of categorical variables, this is the tool to use. So I'm going to show you an example, and it works pretty well. Yes, Harry.
Just throwing it out there. I think either LightGBM and or XGBoost recently added support for categorical values as well.
Okay.
So
That's
I like the more modern versions of them.
more modern versions will help. Yeah. If that's the case, then
They keep on improving them.
yeah, that's the great point. So feature importances, SHAP is included. Grid search versus random, that's the two versions I'm using right now. People have been asking me for HyperOpt, so that's coming. So again, 3 steps, very simple process: pip install, next import AutoViml. It throws it into a folder called AutoViml. From that folder, you have to import a function called AutoViml.AutoViml. So you import that, and you have to just call the AutoViml function or method, and you basically have this train target test. These are all the various options that you can set, like I mentioned earlier. So you just set them to true or false. And currently, the default settings that I have will give you a pretty good model. But if you feel like you need to play around, get something better because your data set requires those extra features or extra tuning, you can do that by just changing the false to true. Here, binning false to true, stacking false to true. And you can see step by step whether it improves your model or degrades your model. Got it? This is probably what will help you the most, in my opinion, when you're sitting in front of a Jupyter Notebook and you can just use one line of code. Use your data set, send it in. You don't have to do any changing. It takes care of missing values, it takes care of categorical values, turning them into numeric, all of that is done for you behind the scenes. Right? Okay, so this is kind of, again, pip install, linear model. We're going to look at its data set. This is the data set, which is the Boston housing data set that you saw. When you run it through AutoViml, the data set size is 506 rows and 14 variables. It reduces them by 24%. Yeah, 10 minutes, yeah. The time taken to build a model was 6 seconds from data to model. And variable selected, it selected 10 variables out of 14. And you can see the feature importance chart right away. You can see the results. So first we started with the linear model. The results are the following. The root mean square error, which is the one I look at, is about 3.00. And it's in the middle. I give you all other things. If you move it to just setting it, so change one of the settings to bagging model. I had a flag called boosting versus bagging. If you change it to bagging, it will give you a random forest model. Right? So just one line in one flag change, you get a different model. You say boosting, set that flag to true, then you'll get a boosting model and you'll get sharp values. And if you think you're done, you got more. You can turn the interaction variables on while you're in the linear. Then you want to have the random forest, you want to come up with the binning of the numeric variables, you turn that on while you're in the random forest. While you're doing that, you just want to turn on ensembling, you want to see ensemble and binning, and then you want XGBoost with stacking. So basically you can try a lot of different combinations. And the reason for doing this is, one guy said, why did you make me do all this? You could have just gone through all of the iterations yourself and just tell me the best model. So we don't have to do anything, right? We just send the data, you tell us, then it becomes a black box, right? Once again, you started coming to this tool because you wanted some kind of control over how you built a model, and then you are again telling me, just forget everything, build me another black box. You cannot satisfy humans. But what you want to do is, if you feel that is your goal and you want to automate this, write a for loop that changes true to false, false to true for every one of these variables, and have it just print it out. It'll take you 2 minutes of code to write that, turn this into a black box. It's not a big deal, right? And you can perhaps sell that too. So it's just not a very difficult thing to do for me to actually change everything, look for what results come out and give you another black box. But what most data scientists prefer, instead, they want to have granular control over what they are building. Got it? That's the reason. Okay, so in the machine learning process, where do these stand? In the AutoViml stands in the exploratory data stage, and AutoViml does most of this and comes out with supposedly an optimal model. And your job then is to take the new data, the steps that AutoViml has given you, write your pipeline for the steps that you need to do for your data to be able to then take the optimal model that it just generated for you to write it. Okay, any questions? We don't eliminate the need for data scientists, but we speed up the tasks that they are spending time on. There is a Wisconsin breast cancer data set that goes like this. It's got X number of rows, forget the exact number of rows, but we'll see it. And then you can see the AutoCAC curve generated by AutoViml, almost like straight up to the right. It's pretty hard to do on your own. So it's helpful, that's all I'm trying to say. One person asked me, what do you use it for in your own job? I use it as a baseline model. So if I were to have a challenger sit with me in every project and challenge me to do better, that would be AutoViml. It would challenge me to beat it, right? So if you were to build a baseline model, if AutoViml were to build a pretty good baseline model, then you as a data scientist should be able to come up with a slightly better model. Right? That's the idea. So it took 12 seconds. It was a 512 rows, took 12 seconds to build a model. It reduced the number of features in that data set by 52%. So the model that it built had 52% fewer features than the models that others have built. And yet you saw the results to the right on the charts. That's quite, useful.
So would you be actively adding relevant and new models or ways of developing models?
Yes. So currently I think it cycles through about 15 different models to come up with something that's useful for you. All right, what's the next step? What's missing? In no feature engineering, currently it doesn't do any feature engineering at all, except for the three I mentioned. One person said, I already have a lot of tools that do feature engineering. I don't know if you've heard of MIT, had a tool called Feature Tools, which is open source. They've open sourced it. Basically, it creates a lot of features out of your data. So you can take your data set, use MIT's Feature Tools, creates hundreds of features out of your data. Only problem, if you were to feed all of those features, they are all, 99% of them are highly correlated to each other. So your model becomes even worse than when you started with. And the person gets very confused. How did this happen? Right? So you need something like AutoViml that cuts the number of redundant features, highly correlated features down. If it is able to do this for very famous data sets where people have actually condensed them down to 13 variables, and it still cuts them down, you can imagine what it will do to feature tools data. It will just, it will slice through them. So after you generate your features, through whatever tool or your intuition, run them through AutoViml to make sure you cut the features down to size. Right? Any questions, Brian, or anybody from your experiences you want to share? Is this something that you look at, or?
Is what is?
Like AutoML kind of tools.
Well, I'll probably go to GitHub and take a look at this later and just see. It looks impressive. It looks like you can do there's a lot of functionality.
Yeah, it's not well known yet, but hopefully it'll start to pick up. That's why I said, it's either the best kept secret or it's probably the worst tool that I've built.
Is there any other tools on the market now that generate all those plots automatically?
No, not that I know of. So there's a similarly named tool out of another company that does somewhat things like this, like AutoVis does, but I think we look at it very differently. I didn't name the tool after them. I kind of had been building something like this for 2.5 years before I heard of them, but after I put it out, people said, oh, there's another tool in the market that actually does something similar. But I've looked at it, and there's just no similarity in what charts and graphs we generate, but apparently somebody has a similar idea. Not surprised. But mine is open source, so anybody's willing to, market it, take it, give it a different name, they are welcome to.
Your tool is look a lot like Data Robot.
I'm sorry?
Your tool is look a lot like Data Robot.
It looks a lot like Data Robot. Which tool? The AutoViml or
AutoViml, the displays of the chart.
the displays of the charts? Huh.
Like you generate those charts.
Okay. I don't know. I have not heard
But
that.
the way that you generate the feature important. I mean, many packages allow you to generate the feature.
Yeah,
But the additional charts that you want to evaluate for the features,
yeah.
it's look a lot like Data Robot.
Okay, good. I'm very happy to know that. I've never used that tool, but I'm very happy that the thinking is about the same. There is a lot of room for improving, innovating on this tool. I feel like these are early days for both of these tools. A lot of people, fortunately, are coming together to help to make it, test it, and so on multiple data sets. So we are also looking at benchmarking them and so on against other tools. So hopefully one day we'll be able to come up with some news. No video, no image, no time series, no neural networks. The list goes on. Model serving, you can add a module for serving. AutoViml, what's missing? It's currently not built into anything. It's just standalone. Idea would be to, if you want to, visualize something fast, you just have to hook it up to AutoViml and feed your data. Let's say somebody's got a device that generates a lot of data, but in the end, they need to produce a dashboard out of those, or they want to produce some charts out of it as the data comes in. Instead of writing millions of lines of code, they can just feed it to AutoViml, take the charts that come out, and show only the ones that they feel are needed. It reduces the code, so that's something to think about. I've kind of tried to make people aware in colleges and students. It might be easy to just not have to write any code when you have a college homework or a project, a school project, Just feed the data to AutoViml and get all your charts in a jiffy. All right, what's missing? Pie charts, mosaic charts. There are a lot more charts that can be built into IoT tools and so on. So, all right, so now I'm going to do the demo of this tool, and with that we'll close. Okay. So hopefully this will work. Okay, so this is the breast cancer data set where we have. I'm going to start with something really simple. I want to keep the. So we heard about the Boston data set. Right. So the Boston data set has a separator that's a little different. It's /tab. So if you run the Boston data set through median value, it starts to build a model pretty quickly. It goes through these features, and the number of features are 13 features, and it tells you an estimate of how long it will take to build a model. It's about 0.3 minutes. I know what that's like 20 seconds or so. We'll see how long it takes. And it'll tell you, based on the estimate, how long it actually took to build a model. It shows you all of the steps it took to get there. So you can see how it categorized the variables, what variables it found, whether there were any missing values and so on. So in this particular case, it's taking a little longer than normal.
Do you have any plans for supporting like a cluster, like a compute cluster for this stuff?
Yeah, some people have approached me about putting it as a machine image with AutoViml and AutoViml built in. So in that case, all they would do is to load up the machine and they would just have it automatically in there. So that's one way to do it. All right, so it's completed it. I see that the time that it took to train, the model training time was 58 seconds. So it predicted a little bit lower than what it was actually taking. My data set here, the RMSE is 2.59, and you can see all the charts it generates, and then you can see the feature importances, and then you can actually test if indeed your regression model, what the values you got in the test data set. It's been a long time. All of these are available for you to play with, but basically it shows you on the test data the kind of results you're getting. Okay, so we're going to change this to a different data set now. We are going to try the iris, which is kind of a famous data set. The iris data set's target variable, I think, is like type class or something. I'm not sure the exact name. And then, so there are only a couple of things that you'll have to change. You'll have to change the name of your data set, where it is found. You'll have to give it the separator that's in the file, so it's a comma. And then the name of the target variable, I think it's class now. Sometimes I work on different iris data sets that have different names for the target variable. So class is the name of the target variable. This splits it into test and train. And basically you start running and you don't have to change a thing. You don't have to change any line of code, right? So here it's going to train. It says it's going to take 0 minutes. But you can see that the code is so simple. It's just one line. You don't have to tell anything about the data. It understands it. If it's clean, unclean, what kind of features, everything is taken care of for you. So, okay, it's pretty nice results, all position, all 100%. But you're going to test it on, so all of the feature importances, charts, all of these will be helpful to you if you are looking at them. And finally, we are going to test it against a data set that's almost having 100% these variables, breast cancer, I think it's got a hyphen. Okay, so the hyphen data set and the variable target, I got to change it to class, which is capital C. So this data set is unique in the sense that all the variables in this data set are categorical. The age is 40 to 49. The menopause is GE40. The tumor size is between 40 and 44. The invert nodes is between 15 and 17. So all of these are categorical variables, so that's why they are within string quotes. So a data set that's predominantly categorical will have a difficult time. Your standard models will have a very difficult time. So that's where CatBoost is used. So in this particular case, we're going to use CatBoost, and you can see here that it's using the CatBoost model. It is so fast on small data sets, it finishes like the moment I press the run button. So that's the good thing about CatBoost, and I wanted to show you this particular one, which is name balance score. Okay. So you can basically look at it, but that's about the end of the presentation. Any last minute questions? Yeah. Okay, thank you all for coming in the snow, and I really appreciate the opportunity to talk to you.